This video will teach you how to investigate cases where the SCAN tool's reported data differs from what you measured directly at the vehicle or module. Understand the reasons for mismatch and the right steps to take. Before a fault, most technicians expect SCAN data to match what they see with a DMM or scope. But when the CAN reported value disagrees with local meter readings or symptoms, this points to network, reference, or input circuit issues. It could also signal module logic limitations. The ECU cannot see the whole world. It only registers voltages or frequency on its input pins, reference to its local ground and supply. If there's a wiring issue, offset, or if what's delivered over CAN is altered by module logic, the reported data can mislead. Even when test conditions and symptoms are clear, SCAN data may report a value very different from what you measure at the sensor, actuator, or module connector. Comparing expected values, related live PIDs, and physical readings side by side helps highlight where the trust breaks down. Let's take a closer look at data flow, the sensor output, what the module receives, and what the SCAN tool displays. CAN data can lag, be averaged, or be corrupted by an offset in ground or power. Placing a meter or scope at the sensor pin and comparing to SCAN data can catch issues, not just sensor or module faults, but circuit and reference problems too. To diagnose data disagreement, test all three circuit legs: reference power, ground, and signal. Use a meter or scope to back probe at the sensor, connector, and module. Look for offset, voltage drop, or loss under load. Repeat under the same operating condition that triggers the mismatch. Don't replace parts based on a single SCAN value or even a single local measurement. Mismatches are often caused by circuit issues, shared references, or even module translation errors. Always triangulate SCAN data, direct measurement, and symptom for proof. Your practical workflow: reproduce the condition. Compare SCAN data to known good and your own measurements at key points: sensor, harness, and module. Trace offsets, drops, or logic failures to the correct fault source before taking action. CAN reported data is only as trustworthy as the entire input, circuit, and logic path. Always confirm with direct measurement and reproduce the exact conditions before trusting or acting on a SCAN tool value. You've just learned how to diagnose CAN data mismatches by combining SCAN tool evidence with real measurements and system logic. Keep applying these methods for accurate, repeatable diagnostics.